In this video, I'm going to go through two examples using the equation in Newton's second law, which is F net equals m times a, F net equals net force in newtons, m is mass in kilograms, a is acceleration in meters per second squared, and then I will also talk about a few concepts that relate to Newton's second law. So here is the first problem that we will be working on. First thing we need to do for this problem is convert grams to kilograms, because with Newton's second law equation, mass will always be in kilograms. An easy way to do this is if I remember the metric prefixes, which I remember using the acronym King Henry died by drinking chocolate milk. By is our base unit, and then we go this direction towards K, which is kilograms, or king in the remembering device I used. So deca, hecta, kilo, and that is now my mass in kilograms. Otherwise, you can do 8 grams times 1 kilogram over 1,000 grams, and you'll arrive at the same answer. For this particular problem, we do not have to rearrange our equation. We are looking at force, and we're going to multiply that. To find that, we are going to multiply the mass that we just found in kilograms by the acceleration of 4.4 times 10 to the 5th, that's meters per second squared. I have cleared my board so that we can take a look at the next problem, which is this one. In this problem, we are looking for the acceleration of the semi-truck. And if we use this circle method here, we can just cover up the a, the thing that we do not know, and we get an equation that is F net divided by the mass. So that would be F net Otherwise, if you needed to see the algebra, what we would be doing is this, and I recommend doing it before you put in the numbers. I divide by mass, this cancels out, and I arrive at the same equation, F net divided by mass equals acceleration. Okay, so let me pause and clear my board again. My board is cleared for the problem, and looking at the word problem, we are given a net force that equals 3,520 newtons north, and we're given a mass that is 23,000 kilograms. Then our next step is to simply plug in the numbers. And if you wanted to go back to color coding as I did before, you can. In this case, I'm going to just stick with a non-color coded problem. So I've got 3,520 newtons divided by 23,000 kilograms equals our acceleration. last two math concepts for this video. The first is when net force is constant, mass and acceleration are inversely proportional. So what this means is that we had in the first word problem a bullet with a small mass and a large acceleration. In the second problem, we kept the same net force, but then we looked at a semi-truck with a much larger mass and found that it had a smaller acceleration. Another way to look at this is that if we keep net force constant and we increase our mass, we'll decrease the acceleration. We can also go the other direction of where if we decrease the mass, we increase the acceleration. Second concept is that net force and acceleration are directly proportional when mass is constant. So if the net force is doubled, then the acceleration is also going to be doubled. If we decrease the net force by a third, we would also have to decrease acceleration by a third as well. And that is all I have for this video. I will see you in the next one.